Physics. Experiment number 1. Aim: to study the dependence of potential difference V across a resistor on the current I passing through it and determine its resistance. Also plot a graph between V and I. Apparatus and materials required. DC voltmeter 0 to 5V, DC ammeter 0 to 5A, connecting wires, rheostat, key, battery or an eliminator, a resistor, sandpaper, etc. Theory. According to Ohm's law, if physical conditions of a conductor remain the same, the current I flowing through it is directly proportional to the potential difference V applied across it. Mathematically, current directly proportionate to voltage, or voltage directly proportionate to current, or voltage is equal to product of current and resistance. Where R is the resistance of the conductor, it is measured in ohm. When V increases, I also increases, and the ratio V by I always remains constant. Here, B is equal to battery, RH is rheostat, R is equal to resistance, V is equal to voltmeter, A is equal to ammeter, K is equal to key. Figure 1. Circuit diagram for verification of Ohm's law. Procedure. Arrange the apparatus on the table and assemble the various parts according to the above circuit diagram as in figure 1. Components layout of this experiment is shown in the figure 2. Adjust the rheostat for minimum current. Insert the key and note the value of I and V from the ammeter and voltmeter respectively. Repeat this experiment 5 to 7 times by increasing the current step by step by adjusting the rheostat, and note the values of I and V in the table. Calculate the ratio V divided by I. Plot the graph between V and I. Here is figure 2. Demonstration of Ohm's law, components layout. Observations and calculations. Now, record all the observations in the following table and calculate the values. Result. The experiment shows that value of V divided by I is practically constant, which is called resistance. It verifies the Ohm's law. The graph V along y-axis and I along x-axis is a straight line. Slope of the line is equal to resistance. Precautions. The connecting wires should be thick copper wires. The insulation of ends of connecting wires should be removed using the sandpaper. Connections should be tight, otherwise some external resistance may introduce in the circuit. The ammeter should be connected in series with the resistor such that the current enters at the positive terminal and leaves at the negative terminal of the ammeter. Voltmeter should always be connected in parallel to resistor. The pointers of the ammeter and voltmeter should be at 0 mark when no current through the circuit. Current should be passed through the circuit for a short time while taking observations. Otherwise, current would cause unnecessary heating in the circuit. Heating may change the resistance of resistors.